Hey, this is Dr. B, and let's talk about enthalpy. It's very similar to heat. It is the heat change at constant pressure. That means when you have an open system, uncorked, if you will. The term used for enthalpy is H, and since it would involve a change in enthalpy, that's delta H, and if it involved a chemical reaction, well, we just add that subscript. Comparing it to heat is given in the definition. If it's an open system, they are synonymous. We oftentimes measure these things with a calorimeter, like this one shown here. In this case, since this is an open system, the change in heat is the same as the change in enthalpy. By convention, if it's releasing heat, and typically calorimeters do show a release in heat, they get hotter, the solutions get hotter. The reaction is defined as being exothermic. If it requires heat, well, that's endothermic, where delta H is positive. Okay, let's imagine we're melting some ice. So it's at 0 degrees and it's turning from ice to liquid water. Measuring this, we find that it takes 6,010 joules for that ice cube, which is 1 mole's worth. We could write this thermochemically. That means write the chemical reaction and include the energy change. And there it is. There's the chemical reaction, although it's not, right? This is actually just a physical process. It's okay for a thermochemical equation. It doesn't require a chemical reaction. And it's endothermic to the tune of 6 kilojoules per mole. And so that's what you write. And sometimes people add it right here on the reactant side since it requires energy, where they're treating energy like it's a chemical, which I always thought is kind of weird. And let's finally solve one problem to complete our little study here. It says that if you burn a mole of methane, you will release lots of energy. Good. We can write that thermochemically. This time let's put a negative sign for our change in enthalpy. And make sure you have a balanced chemical equation. We do. Methane plus oxygen makes CO2 plus water. And now let's solve the problem. How much energy is released during the formation of 12 grams of water by the combustion of methane? Well, we have for every 36 grams of water, we release this much energy. Do you see that? For every 2 moles. But we're only dealing with 2/3 of a mole. So let's just start with what we're given. We have those 12 grams of water that we're producing. And for every mole of water, well, we have 2/3 of a mole. That shows us right there. And for every 2 moles of water, notice that it cancels nicely, we are releasing 8.904 kilojoules, the same thing as 8,904 joules. So when you make those 12 grams of water, you have released 2.968 kilojoules of energy. That's a typical sort of enthalpy problem. This is an introduction to enthalpy.